All right, week 5, we're going to talk about dimensional measurement equipment and spreadsheet analysis. This is course content of the week. So we're going to talk about vernier caliper parts. We're going to talk about how to use them. And then we're going to talk about some spreadsheet programs such as Excel. Okay, this is a vernier caliper. It is basically used for inside and measuring inside and outside lengths. It is frequently used in industry too. So these are real practical measurements. So it is good to learn how to use them. So let's talk about the vernier caliper parts. Here, this thing we're gonna call it main scale. Okay, this is main scale, and on the bottom and on the top, which these are same, we're gonna call it vernier scale. And with combining these two scales, we're gonna tell how much long my part is, my measurement is. So let's say, let me delete these things first. So let's say you want to measure your part, and your part is this. You see, this is your part. Let me draw it here actually. So this is your part. So let's say you want to measure this diameter. Okay. How do you use your vernier caliper? So you see your external jaws. You can use your external jaws to measure this length. How? Just like that. It is illustrated here. And for inner diameter, let's say you want to measure this distance, this diameter. How do you use it? Can you use external jaws? No, it is not possible. It wouldn't be precise. So that's why you're going to use your internal jaws, just like that. Okay, you're using your internal jaws. You're just placing them. Then you're going to measure. And let's say you want to measure now. So we want to measure this length here, which is depth. Okay. If you want to measure depth with your vernier caliper, you're going to use this depth measuring blade, which is illustrated here. Okay. This is how you measure your depth. And we have a locking screw here. Why do we use it? So let's say you placed your jaws, and after that you can just lock your screw here, and then you can apart your vernier caliper. Then you can read it easily. This is what this is. This screw is for it. And we have examples. Okay, how do we read our vernier calipers? So here, this is my main scale, right? And in main scale, this is my main scale. In main scale, every interval is equal to 1 millimeter, all right? So 1 millimeter, 2, 3, 4, 5. And these are 5 millimeters, okay? And between this thing and this thing, so between 9 and 10, I have 10 millimeter, for example. Because I have 10 intervals, I have 10 intervals, yeah. Okay, so this is my main scale, and in my vernier scale, this whole thing is representing 1 millimeter. Okay, therefore from 0 to 1 is 0.1 millimeter. It is representing 0.1 millimeter. And since I have 5 intervals between 0 to 1, that means every interval, let's call it V. So every interval V is equal to 0.1 millimeter divided by 5, right? So that means every interval in my Vernal caliper is going to be equal to 0.02 millimeter, okay? And this is called your sensitivity, okay? You can measure, you can detect 0.02 millimeter with this Vernal caliper. So, all right, we talked about this. Let's talk about how to measure it now. Let me delete my things first. All right. So at some point, your main scale, which is this, your main scale and your vernal scale is corresponds. Okay, they are intersect. So you can see in this figure, which it is sculpted version of it. So at some point here, they are corresponding, they are intersecting. So at this point, they are intersecting, right? Let's start with main scale. You're always starting with your main scale. On your main scale, you have, at this corresponding point, you have, so this is 0.5, right? You have 0.5. How many intervals do you have? You have 1, 2, 3, 4, 5 intervals. And each interval was 1 millimeter in main scale, right? So you have 5 millimeter. You have your 5 millimeter. Then plus, you're gonna say your plus. You're gonna start to reading your vernal scale now. In your vernal scale, you're going to see at some point my lines are corresponding to each other. They are aligned. So in 1, 2 here, these two lines are aligned. So I have 2 times V. And remember what was V? V was your sensitivity, which was 0.02, right? And that is going to be equal to 504 millimeter. All right. Here in this version, you can see it's at this point, it is corresponded. And after that, you're going to start to reading your vernal scale. And here they are perfectly aligned. And that is to mean you have 2 times V measurements in your vernal scale. And then you're going to add them up like this. So 5 times, I have 2 intervals in my vernal scale, and my V was 0.02, and that is equal to 504 millimeter. Okay, this is our first example. Let's talk about the second example now. Here, all right, I'm just going to, so this is your example, this is your sculpted version. Okay, this is my reading. Let's find V first. What was V? V was my sensitivity. In my vernal scale, this was representing 1 millimeter, right? And from 0 to 1, it is going to be representing 0.0 millimeter. And that means, since I have 2 intervals between 0.0 millimeter, that means every interval, which is sensitivity, is equal to 0.1 divided by 2, which is equal to 0.05 millimeter. So I found my V now. So let's start reading now. In main scale, I have 1, 2, 3, 4, 5 millimeter. Okay, 5 millimeter. Plus, let's start to read vernal scale now. Plus, I'm looking for where these lines are perfectly aligned. Let's see. So, all right, this is perfectly aligned now, right? So at one point, so remember each intervals was 0.05 millimeter, right? And how many intervals do I have from this point to this point? I have 2, 4, 6, 8, 10, 11, 13. I have 13 intervals of V. And what is that going to be equal to? So V was this value, right? And just add them, and that is going to be equal to 5.65 millimeter. Okay. An easier way to, so this is how you can read. This is one version. This version of reading is for getting intuition of it. But for being more practical, you can always read it like this. And let's talk about it now. So let's read it again. You have your own 0.5. So this is 0.5. And this is 0.6, by the way. Okay. You are on 0.5. So in your main scale, you have 0.5. Just multiply this by 10. Okay. And then add your so let's say you have 6, this is your aligned, this is where you're aligned. So this is 6.5, right? 6.5, and multiply this by 0.1, and that is going to be equal to 5 plus 0.65, and that is going to be also 5.65. Okay, this is another practical version of it. Let's keep going. Also, we have digital vernier calipers, digital calipers. Basically, it is more practical. You can see on this, you can see these in industry too. It basically tells your output immediately. You don't have to read like this. Okay? We have simulations. We're gonna share these simulations with you. Also, we're gonna talk about how to use them. You have some different sensitivities with these. So this is your sensitivity. This is your sensitivity, but they are different. Okay. How did we tell our sensitivity? Remember, this was going to represent 1 millimeter, and this was going to represent 0.1 millimeter, and each interval was 0.1 millimeter. So in 0 to 1, I have one interval, and that is going to be equal to 1 millimeter. This is my sensitivity also. Okay, now we have our simulations. Let's get into it. All right, as I told before, we have simulations with these vernier calipers that enables us to solve some examples. So here we have simulation 5. We are also going to be sharing these with you so you can exercise on your own. But let's start together how to solve these problems. So this is simulation 5. I can always use this version. This is easier for me. You can choose either one. So basically, it is asking us a questions. What is the reading? What is the interpretation of this vernier caliper? So let's start the reading. Remember, first we are starting with reading main scale. So this was my main scale. And on my main scale, I had one interval. So I am on first. interval. I am on first line, so it is 1 point something. So after that, after the point, I'm going to start reading my vernal scale, which is just, and I am looking for an align point. So my lines are aligned just here, right? So how many points are aligned? So how many points do I have? I have 6 points. So I'm just going to say 1.6 now. So it says correct. Let's solve another one. So here I am on, let's start with main scale, like always we do. I am on 1 again, just 1 point something. And on after the point, I was looking for vernal scale. I'm on 8, just 8, easy. So now I have sensitivity. So let's see for main scale now first. On my main scale, I am at 1, 2, 3, 4. Okay, 4 point something. After the point, I am looking for vernal scale. And this point is aligned, this line is aligned, then it is 0.5. If this point was aligned, I was going to say, if this line was aligned, then I was going to say 1, but not this point, but this, not this line, but this line is aligned, then I'm going to say 0.5. Correct. Let's keep going. Again, let's see, in my main scale, I have 1, 2, 3, so 3 point something. And in my vernal scale, I have 1, 2, so 3.2. All right, keep going. Main scale, now I have, remember it was 0, right? So this line is 15. Can you see that? This line is 15, and this line is 14, and this line is 13, okay? Because here I have 1. So I'm going to say 13 point something, 15, 14, 13. So, okay, 13. After the 13, in my vernal scale, in 8th line, I have the lines. Then I'm going to say 8, okay? Let's keep going. So now, in my main scale, so see, this is 30, this is 25, okay? I am on 25 actually, 25 point something. And in my vernal scale, I am on 65. If I was here, then I'm going to say 60, but I'm not here, I'm on 65. Okay. All right, keep going. Here, this is 80. This is 7 to 9. This is 7 to 8. This is 7 to 7. So 77 point something. And after the point, I'm looking for my vernal scale, and I am on 55. All right, it's correct. Let's keep going. Let's solve some harder examples, honestly. Let's go. All right. See, this is 100. Right? And this is 95, okay? This line is 95, this line is 96, so 96 points. After the point, I was always looking for my vernal scale. I am aligned at this point, so this is 30. Okay? And it keeps going like that. I am asking for you to solve these problems, or solve these examples on your own. That will help you a lot. And all right, now let's talk about spreadsheet programs. These ones are older versions. We are going to use Microsoft Excel, okay? And you can download and use any Microsoft product, and that includes Microsoft Excel too, with your email. student email. Okay, so use your student email to download Microsoft Excel free. Okay, we have Excel functions depending on your Excel language. If it's in Turkish, you can use these formulas, okay, topla, ortalama, ortanca, and things like that. And if it's in English, your formulation going to change. You have to use these formulas, okay? And we're going to talk about these functions. I can show directly it's with Excel. I'm going to open Excel now. So here, this is my Excel, okay? I'm going to write my data first. Let's say I have, so this is E. I have, let's say, 5 measurements. Okay, I made 5 measurements. I'm going to write them like this, okay? And I'm going to write in this column, here in this column, I'm going to write my measurements. Let's say I have 1, 6, 7, 10, and 3, okay? So these are my measurements. These are my number. So this first measurement is 1, second measurement is 6, and things like that. So I want to visualize it like this. It will ease my solution. It will ease my visualization. So let's do it like this. Okay. So if I want to see, so what do I want to see? I want to see sum. I want to see mean. I want to see median. Okay. I want to see mode. I want to see standard deviation. I want to see my variance, okay, in this block. So I can say, so here I'm going to write equal to, and after the equal, you're going to write your formula, your function, okay? What is my function for sum? And since my Excel is in Turkish, I'm going to say topla, open my parentheses, and inside my parentheses, I'm going to write I am on C3, double dot, C7, okay? And then I'm going to say enter. Also, you can write it like this. Topla, parentheses, I am starting with C3, double dot, and I am ending up with C7. Close my parentheses, plus enter, okay? For mean, I have another formula, which is ortalama, okay? Double parentheses, get into the parentheses, and you can do like this too, okay? You can use your cursor. Here, you have your mean. For median, you can use, and again, equal, then my formula is ortanca. Double parentheses, get into the parentheses, then choose your interval with your cursor, press enter, okay? In your modes, I have equal again, and my formula is this, okay? Then choose your interval, close your parentheses, press enter. So it says my mode does not exist. Why it says that? It is because, you know, so each of these elements are repeated once. And therefore, I don't have a mode. But if I say, you know, I have 2 tens, then it is going to say your mode is 10, okay? Then standard deviation. For that, let's say equal again. Then I have my this equation. And I'm going to choose my interval, close parentheses, and hit enter. For variance, my formula is this. I'm going to choose my interval, close parentheses, hit enter, okay? Good thing with Excel is that you can always change this numbers now. You can say, you know, it is 9, and your answer is going to change immediately. So it was 3, for example. You can change them. Say this is 3, this is 7, this is 1. Okay, you can always change this interval. You can always change this numbers, and it will automatically tell your answers. So one more thing that I want to show. All right, one more thing that I want to show you is that curve fitting. Let's say I have these data now, and I want to fit a curve into these points. How do I do that? I'm just going to select my data, and here in Ekle, I'm going to choose this one. Okay, and here I have this. I'm clicking this one. Here I have versions of fitting data. I'm going to say if you want to fit a linear data, you're going to choose this one. Okay. If you want to fit a polynomial, which I want to fit a polynomial, you're going to click this one. Okay. And here a second degree polynomial is fitted, but I want higher degrees. So it is third degree, fourth degree. And let's say I want to fit a 4th degree polynomial. Therefore, I write 4 here. Then I'm going to choose this one, click this one. So it basically shows me my fitted polynomial. Okay. Then I'm going to hit enter. Okay. So here I have my fitted polynomial. You can always change these data, and automatically the answer is going to change, which is pretty cool. Okay. And that's all. Okay. Now let's talk about GM codes. GM codes are pretty fun to work with. You remember we have talked about CNC machines before. What was CNC machine? It was basically a manufacturing machine, but it is aided with computers. Okay, so here this is your panel. Okay, you're writing your codes here, and your CNC machine is doing the operations for you. Here, this is the CNC interface, one example of it. And we're going to solve some examples. So here, this is my GM codes, okay? These codes are used for controlling CNC milling and controlling CNC lathes, okay? We have G codes and we have M codes. For example, GOO. By the way, we have so much more codes than this, but here these are some basics ones. We're going to use this one, this one, this one, this one, this one, maybe this one in our examples, okay? So what these codes do. So GOO is a fast motion of the end effector, okay? GO1 is linear cutting speed. So you want your cutter, you want your end effector, you want your cutter to move with a linear cutting speed. So you're moving, for example, your cutter here, okay, in space, and you want your cutter to go this way, okay, but with a linear motion. So you're going to use GO1. So GO2, it is clockwise circular motion. Let's say your end effector, your cutter is here this time, okay? And you want your cutter to go with clockwise motion like this, okay? So you're going to use GO2. If it's counterclockwise, if you want that to be like this, then you're going to use GO3, okay? So M codes, here this one ends the program. Basically, this is an end statement. After you're finishing your code, you're going to write M30. Here we have an example. Okay, let's solve the examples. Here, this is my cheat sheet, okay? You can find these codes right here. I just copied here, pasted here, so I can look. Here we have an example. So in that example, what it wants is that here, this is my profile. Okay, I'm going to mill this profile, but the depth, which is Z, is going to be equal to -3 millimeter. Okay. And my feed rate here, this is my feed rate, is going to be 100 millimeter per minute. Okay. And I have my feed too, which is 100 millimeter per minute. Okay. So what is my code? And the problem says that my end effector, my cutter, is at 0, 0 as the initial point. Okay. So I'm starting the code now. So here you see these N codes. These are basically your line numbers. So you're going to say I am at N101, then you're going to start to write your code, okay? N101, your code. Then I'm going for second line, I'm writing N102, then I'm starting to writing my code, okay? So let's start. So in the first line, what I did is that I want to send my end effectors, I want to send my cutter to Z20. Why? Because, you know, I want my cutter to go a safe position first, which is Z20, okay? Here, this profile is at Z-3, right? So I am at Z20 now. So this is, if this is your side view, let's say, and this is your solid, okay, that you want to machine. Z20 is somewhere here, okay? My cutter is here now. And let's say this point is 0, 0, 0 on X, Y, Z. Okay? I'm sending my cutter to Z20 now. With GOO, what is GOO? It is a fast motion. I can go fast on space, but I cannot go fast on the material. Since I am on the space, I can use GOO. And after that, what I want to do is that, let's say in this position, which is P1, I want to go to the position P1 where I am starting to machine my solid. To send end effector from here to there, I'm using again GOO, which is fast motion, and I'm writing my position, my desired position. What is that? So here, this is P1, X is -40, X -40, Y minus 20, and Z -20. Again, I was on Z, and I'm going to Z again, Z20 again. And after that, now I am here, okay? I want to get close to this solid. So I want to go there. So again, I'm writing GOO, and I want to go on Z, right? I want to move to Z. So I'm writing Z 1 meter. So I'm getting close to the solid, and I am 1 millimeter away from it now after this line is proceeded. And after that, here, I want to start machining. That is to say, so I want a depth. Let me write solid again. So this is my solid, and I was here, and I want to go into depth of -3 here. I want to move along from here to there. And what I'm going to use now, I cannot use GOO because it was a fast motion, and I was using that fast motion only on space. Now I want to machine my solid, so I'm going to use GO1. And remember, what was GO1? It was feet with linear cutting speed. So GO1, and then I want to I want to state, where do I go? I am going to Z -3, right? This is Z -3. This is P1. And after that, I am using F code here. And what is F? F is your feed rate. Remember, it was 100 millimeter per minute. So F 100 will do my job. All right, now after that, now I am on P1. So what I'm going to do is I'm not going to change my elevation because it was constant, it was -3. Okay, I'm not going to change my elevation. I'm not going to change my Z. What I'm going to do is that I'm going to go P1 to P2, then P3, then P4, then P5, then P6, then P7, then P1. All right, let's write the code for it. So I am it here, and I want to go P2. So GO1, because I am making a slow motion, feed motion, that's why I'm using GO1. Here, notice I'm not using GOO. Then after that, I'm writing my positions, which is this, X0, Y -3. After that, I am on P2 now. I want to go P3. Again, my X is not changing, but my Y is changing. So I can just write Y -30 here. I don't have to write GO1 again, okay? Y -30. And after that, this point to this point, my Y is not changing, but my X is changing. So I'm just writing X5. Press enter again. After that, I am going to go this point to this point. Both my X's and Y's is changing. So I'm going to write X20 and Y -5. I am on P5 now. Then I want to go P6.6. So my X is not changing, but my Y is changing. So I can just write Y. So Y3. And now I am on P6.6. And after that, I want to go a 0.7, which is my X is changing, but my Y is not changing. So I want to go to -40 in X position. Okay, I am here now. So after that, I want to go P1 again, right? Because this is what my example indicates. And my X is not changing, both is -40, but my Y is changing to 30 to -3. So I'm just writing my destination on Y, which is -20. Hit enter again, new line. Now I am at this point again. I am at P1, right? In depth, in -3. So what I want to do now is that I want to go a safe position in space. And after that, I want to go my initial position, which is 0, 0, 20. Okay. For that, I can use, I want to go from here to here. I can use this code for that. Okay. I want to go with 20 etc. Now I am here, okay, in this after this line I am here, and after that I want to go from here to there, and this code will do that. I'm going to go x0, y0, and z0. Okay, I am here now. My cutter is here, and my profile is machined, and I did what I wanted to do. What is going to left? What we have to do now? I just want to end my program, and for that you're going to use this. Okay, you're just going to write M30, and program will stop, cutter will stop, and everything will be stopped, and your profile will be machined. All right, we have another example here, which this one is includes a circular motion here. Okay, so I have again my cheat sheet here. Okay, you can always look on your cheat sheet. You don't have to memorize all the codes. And let's solve the problem. So what problem wants me to solve is that, again, it wants, let me erase this one. Again, it wants a profile like this, and it wants n, which is the depth, to be -3 again. So this is my depth, okay, and it wants my feet to be 100 millimeter. So the conditions are same as the example before we have solved. Okay, so again, let's start to solve the problem. I am at this is my solid. Again, I am here, which is 0, 0, 0. Okay, this is world. And first I want to go into a safe position, which is here. Okay, my cutter was here, and now I want to go here. Okay, for that I'm using GOO, which is fast linear motion, and I'm using elevation of 20 in Z. Okay, now I am here. And after that, I want to go where P1 is. So this is my P1, for example, okay? And the depth is -3. I want to go this position, okay? How do I go from here to here? I'm going to use GOO again, and then I'm going to write my position. So at X, I'm going to be at -40. At Y, I'm going to be at -20, and Z is 20 again. Okay, I am here now. And after that, I want to get close to the surface of the solids, which is here. Okay, I want to go from here to there. Okay, then I'm going to write GOO again, because I can write GOO. Why can I write GOO? Because I can go fast because I'm in space, basically. Okay, so GOO, Z1, now I am really close to my solid. And after that, I want to go from here to there, which is my point P1, my point 1. So I cannot use GOO now because I am touching my solid. So I have to use a slow motion, or a motion with a feet, which that code was GO1, right? Okay, this is GO1. I'm going to write GO1. I'm going to write my Z-3, which is my position 1. And then I have to add my feet, which is F100. Okay, this is my feet here. This is my feet. And after that, I am at P1. Now I want to go P2. How can I go P1 to P2? So my elevation will not going to change. It is going to stay as constant, and it was going to be equal to -3, right? So I am at -3. I don't have to change my elevation. So GO1 here, X0, Y -3. Now I am at point 2. And after that, I want to go P3, which is this. I'm not going to change my 0. I'm not going to change my x, but I'm going to change my y. So I'm just going to write y minus 30. And after that, I am here and I want to go there. Again, I'm going there to there. And my x is changing, but my y is not changing. So x5 will do my work. And after that, here I am here. And it wants me to do this circular motion, okay? And remember, for circular motion, we were using GO3 or GO4. See, my circular motion here is in this way. And what is this? This is counterclockwise motion. Okay. See, you have your clock. Okay. Here you have 12, 1, 2, 3, right? This is your clockwise motion, and this is your counterclockwise motion. Here I have my counterclockwise motion, and for that I'm going to use GO3. Okay, I'm going to use GO3. And what else I'm going to need? So what I'm going to need is that I need my arrival position, which is P7 here. And at P7, I'm starting to write the code. So GO3, my arrival position here, this is x minus 40, y 30. And after that, I'm going to write r, which is going to be my radius, okay? My radius is 20 millimeter, okay? Then I'm going to write my radius r20, okay? And after this line proceeds, I'm going to go from there to there. Now I am on P7. And after P7, I want to go P7 to P1 again. So I'm here, I'm going here again. So my x is not going to change, but my y is going to change. So I'm going to write y minus 30. Okay. Here you can write GO1 minus 32. Okay, it will do the same. And after that, now I am here on point 1. I am here on point 1 again. And what I want to do is that I want to go this safe position, which it was Z20. So I'm going to go GOO. I'm going to write GOO Z20. Now I am here again. And after that position, I want to go to my initial position, which is here. So I'm just writing XO, YO, ZO. Here, my cutter is not there. Everything I wanted is solved. I machined my profile. I am on my starting position, a safe position. Now, what I can do is that I want to end my program. So to end the program, I'm writing M30, which it was here, okay? And that is all for GN codes. And that is all for this week. And see you next week.